Okay, yeah, there is class today. I'm sorry I was late. So what I want to do today is this one. Yeah. So what I want to do today is go through all the data wrangling tools that Tidyverse provides. And what is data wrangling? Well, whatever we do today, that is data wrangling. So you already saw examples with select and stuff like that. And then we want to go through tracing of data wrangling. So that should hopefully help people, especially if you're starting out. So even if you're not just starting out, I think I'm actually going to make you do a little bit more tracing of processing data frames as well. But especially if you're starting out, it might be useful. So especially for beginners, but we'll see. And then just do a few examples. And I mean, you will do them, and I'll help out in class. So hopefully everyone has Tidyverse installed. So we also need Gapminder for today. So Gapminder, to remind people, looks like this. It's a table. So what are the kinds of things that we might like to do with this table? Well, you might like to select a subset of rows. You might like to select a subset of columns. You might like to somehow figure out some property of columns. And like we saw last time, what you might like to do is break the rows up into groups, and then for each group compute the property. So the example that we saw before, and this is going to be a little bit kind of jumping ahead, it is the same example as from last time, but just kind of to show people, to remind people what kind of thing we're going for. So for example, we want to so this is Gapminder. Let's say, the highest life expectancy that was achieved in any country. So generally life expectancies go up, but sometimes things happen, right? So there is a war, that's the more usual situation there, or there is a famine. I don't think that in this data set you have that. In history, of course, sometimes, that's what we want to do. So want the largest life expectancy that each country achieved, right? So I'll do this more complicated example, and then we'll go back to kind of like more elementary things, just going through all the tools that you could possibly want. So how would you do it by hand? So you would say, okay, like I'll look at all the rows for Afghanistan, and I'll see what was the maximum life expectancy in Afghanistan. And the answer is 43 in 2007. So as you see, in Afghanistan, it's, it always went up here. So life expectancy calculations are kind of weird. So this is like a little bit of a digression into data science. Like, what's the life expectancy? It's like if you're born today, if there is no progress, on average, how many years do you expect to live? So this is not a number about any particular person. You have to go back and see at what rate are people dying right now, and then see, okay, like for someone born today, if nothing changes, what the life expectancy would be. Of course, that's not the same as the life expectancy for people born from 20 years ago. So you can't just go back and see, kind of who was born 20 years ago, how long did they live? For one, they're still living mostly, right? So it's actually like not a trivial thing to figure out how to compute it. But people do it to, well, I mean, I don't think to 3 significant figures, so those numbers are kind of like fake. And I know in high school physics they told you to do it. I certainly hope in Physics 180 they'll tell you, especially in physics, but I would say also in social science, you never should be writing this kind of thing if you're not confident about the 0.002 there, it just shouldn't be there because it's misleading to say, oh, I think it's 39.942 when really it's probably like plus or minus a half or something. So anyway, so in different countries, so I think Angola is, so Angola dropped a little bit, as you see, from 82 to 87, stuff like that. So, okay. So how would we do it? So we want the maximum life expectancy that every country achieved. Well, by hand, what would you do? Well, get all the rows, for example, that correspond to Angola, and get the maximum life expectancy out of those rows, right? So that's what tidyverse allows us to do. So it allows us to say group by country, and what that does is this is still the same data frame. Hello. So this is still, you should come. So this is still the same data frame, but the groups are marked out. So there is a group of rows that's for Afghanistan, a group of rows that's for Angola, and so on. And then we say, okay, so summarize. And summarize, if you remember, creates a new data frame with whole new columns which we specify. And here I'll name this new column maximum life expectancy, and I'll say this is max of life exp. So you do this and you get this new table where each group in the group by stage has a corresponding number. So let's now kind of decompose it and trace it. So I'll just make myself so it's hard to trace it on a huge data frame like Gapminder. So what I'll do is I'll make myself a very small data frame, and I'll just kind of like display it like this. So what I'm doing, just kind of so that it's easy, I'm just copy and pasting this, and then don't really need this, and then I'll just make it so that so we'll have a life expectancy here, and we'll have a year here, and then I'll say like Canada, Canada, USA, USA. So Canada, for various reasons, at least recently, has a life expectancy that's a little bit higher than the US. Of course, and some people say it's because like a better kind of Medicare system, and that's possible. Of course, some of that extra life expectancy you spend waiting in line at the hospital, but that's how it goes. And the lines in the US are not much better. But anyway, so we'll say, so I'm just making things up, it's not real. So that's like really not real. So I'll say like in 1980, maybe it was 72, and maybe by 1995, it got to 76. So this is made up. So my rule about not writing digits that I don't believe in doesn't apply because I don't believe in any of those. They're all made up. And we'll make the US be like 70. I don't really know what's super realistic. And then like 75. And that would be 1980, 1995. So, okay. So, and we'll call this G. Right? So this is not R code, not code in the R programming language. This is just to display it. So then we'll say, okay, so what's G group by country? So that's, again, kind of the way we separate out our traces is like this. And we're asking what's, so I'm not really tracing here, I'm just doing like thing by thing. So what's G group by country? Well, it's the same table, except now this is its own group and this is its own group. So I'll mark it as, so here it's very obvious what the groups are. You just look at the country, right? And like this is group 1 and this is group 2. So so sometimes it's not going to be like that later on, so I will mark out the groups like this. All right? So that's group by. So now what's G group by? And then summarize, it's nice to put here, doesn't matter. And by the way, so R was, tidyverse rather, was in large part developed by a guy from New Zealand. So actually he writes summarize with an S, and like that's like the default in the documentation, because that's how they do it in New Zealand. However, in Canada, the more usual thing, well, as you know, kind of summarize with an S would be British, also Australian, New Zealand. So Canada, mostly the spelling follows actually the American convention with some exceptions. So I'm writing summarize like this. And here we're saying max life expectancy. And we're saying max of life exp. So this I now want to trace. So one way to think about it is, oh, that's just max. So I'll just figure it out. But actually it could be any function. It doesn't have to be a built-in function like max. It could be a custom function that you make as well. We'll see it hopefully later on today. So it's worth it to actually trace it. So what are we doing here? So in order to compute this, what we need to do is we need to take the max of life exp in this group and the max of life exp in this group. So how would that work? Well, we are creating a new data frame. And what is this data frame going to be? Well, so there's going to be one column that's the country. And that's going to be group 1, group 2. So I'm taking this Canada, this USA. It happens to be that we just group by country, so it's straightforward. In general, groups could be not corresponding to any one particular column. We'll see examples of that in the future. But for now, country is just going to be the names of the groups. So that would be Canada and USA. And now we have another column, which we said should be called max life exp. And this is going to be max of the elements from life exp that corresponds to Canada. So max C 72.0, 76.0, 0.4. And then max of the other thing, so 70.0, 75.0. Right? So two things to remember here. So if you remember, like this is how we define data. That's interesting. Unable to find function said long face. Why does it want it? That is possible. No, I think it's so I think it's the parentheses. All right. Could not find function said long face. So this seems fine. So we'll do it as okay. Okay, so this seems fine. Okay, someone on Discord knows? Nope. Okay. So yeah. So I'll demonstrate. So I'll struggle with it until it works. So you'll get an example of how to do that. I meant to do this all along, of course. So here what I did is I kind of kept this for the future because I think that might be messing me up. And then I just said I'll make like country is this and max life exp is this. So this I think should work. And yet it doesn't. Okay. I think you're right. So it's because of this. So is it that? Nope. Okay, it's happy about this, and A got defined. So I think what happened is I redefined this thing to something else. So what I'll do, and sometimes that's what you got to do, is I'll restart the environment. That's still no. Okay, I'll comment out the trace. Oh, okay, you're right. Or it was this. Okay, so now I'll go back to this. And now it's fine. I think you were right. I think it was the trace. So that's what we get. So that's how you define data frames, right? So you say like this is one column and then this is the other column. So to go back to what we're doing, so we said max life exp. So what that meant is select out the values of life exp for each group. So in this case, one group was Canada, one group was USA, and then apply the function max to those subsets of the column life exp. Is everyone with me? Is this good? Okay, I'll check Discord. Okay, people are being entertained. Okay. Well, people are complaining about last year's USC 180 handouts. That's okay. Okay, all right. Maybe I'll fix. Wait, were they Unicode? I thought they shouldn't be Unicode. I'm using the literal environment there. Anyway, okay. So sorry about that if I had done that. All right. Anyway, so that's like that, and that traces this like this. So here's another thing that I might like to do that's kind of similar to this. So let's say that was it. Sorry, so just to finish the idea, so this is like this. And then the next thing is we just resolve the maxes. So in this case, the max of 72 and 76.4 is 76.4. And here the max is 75, so just replace this with this. So the usual thing that we do when we trace. There's no max either, so that's like this. And then that's it, that's the output in this case. All right, so let's do something else. So let's ask, okay, so what is the increase in life expectancy for each of the countries? All right. So what's the increase? Well, it's kind of making the assumption that we are just talking about the increase from the earliest year to the latest year and that it's uniform, because I don't want to kind of mess about too much, well, the increase is just the largest life expectancy minus the smallest life expectancy, right? That's the increase. Does that make sense? So just to give an example, so what's the increase in so if this is V, the answer is it's max of V minus min of V, right? Just because you take the largest, divide the smallest, subtract the smallest, that's the increase. So, okay. So now what I'll do is exactly the same thing. So I could actually write it as it happens as max minus min. I want to actually do a custom function. So I'll say exactly what we said before. So max of V minus min of V, that's the increase. And now instead of taking the max, I'll take the increase. Got to do that, right? So now if I define this function, and this is like, I think at this point it gets to be okay, like especially if you're starting out, and even if it's like you have some experience programming but like not in R, I think this probably looks like, whoa, like, you know, like that would take some thinking, probably for most people. You'll get used to it. But also part of it is, okay, like this is not obvious. Yes, it does take some thinking. It's just that I thought about it before class. So we're talking about Gapminder. And here we get kind of the increase. So going more to kind of like the data sciencey stuff is like, are we really interested in the increase? Well, maybe, but maybe probably it's more like we're interested in the percent increase. Maybe that's more useful. And of course you can do it. So like you want the percent increase, just kind of divide this by min of V. Right? So that's like that. So let's trace this, and to trace this, because it's so similar to what we had done before, what I'll do is just copy and paste this, and then just change it around a little bit to show what's going on. So here we now say increase, and now the trace is going to be, so here instead of max we'll say increase. And increase is now a custom function, so max we just wrote out immediately. Increase I want to actually trace. So how do I trace that? Well, instead of increase 7276.4, I'll substitute this in. Right? So we're substituting max of this minus min of this. And similarly here, this is going to be max of this minus min of this. So I'll press and enter here, so that's more aligned. Okay. Next step: compute the maxes, compute the mins. So the max here, so we just substitute 76.4, and we substitute 72. What have we done? Yes. And then we substitute 75.0, and we substitute 70.0. Next time we actually do the math. So that I believe is 4.4. I think I missed the parentheses there, and that's going to be 5.0. So here this is C like this. Yeah. So it's more like this. So one thing I haven't mentioned explicitly, so if you notice, so of course you need to match the parentheses, and if you notice, if you move the cursor, it's going to tell you which is the matching parentheses on the left. So okay, so that's like that, and that's our answer. All right, and that was a little bit tedious. I was a little bit annoyed doing this. And I think you might not like to do it, so I'll make you do it just like once or twice on the next problem set. In general, like I don't do it, I kind of just do things in my head. At the same time, if you're stuck, I think it's a good way forward to just say, okay, like I don't really understand what's going on, but I know the rules of how to trace, so I'll just try to make progress kind of step by step. And a lot of the time, the reason you're doing this is something doesn't work. And if you're doing things step by step with a small example, like at some point you'll see where things break. The problem with trying to do it the other way, where you're kind of trying to make a lot of progress very fast, is that maybe you're not getting anywhere. So I think it's a good technique. All right. So, all right. So that's that, and that wasn't kind of the easiest examples. So I want to now just do a bunch of easy examples with different things. So the functions that I want to show you are arrange, distinct, mutate, and arrange, distinct, mutate. So summarize, we've already seen. And that's good enough. So arrange. So this is basically, so this is like sort. So arrange the rows in a particular order. So for example, to sort Gapminder, so it's sorted by country right now, so maybe instead we want to sort it by year. It's like this, and then you say arrange, and you say arrange by the year. So that's going to look like this. So we start with everything for 1952. And maybe you want like by year and also by continent. So like after you sort by year, within that sort by continent, and you can do it. So you can just say year and then continent. And now you have 1952 and then everything from Africa, and then it would be everything from Asia, whatever, kind of sorted by year, and within the year by continent, just alphabetically. So, and kind of to be clear, so I don't think people have physical dictionaries anymore, so I don't know if people know about dictionary order. I assume they do. But this is kind of analogous to how do we sort words in a dictionary, right? So you have whatever, like this is not actually like the first word in the dictionary usually, but like sometimes, so it starts with like AA, and then like maybe you have zoo, I'll sort it later on, and then you have, well, something topical, so zoonotic, and then you have like whatever, I don't know, What's good? Bat, pangolin. Okay. So stuff like that. So how do you sort it in dictionary order? Well, it's the same principle. So we say first sort by the first letter, right? And then for things that start with the same first letter, look at the second letter, and so on. So in this case, it would be whatever, advark, and then, I don't know how to say it actually, and then bat, and then pangolin, and then we have two words that start with Z, and zoo would come before zoonotic because space comes before everything. So in the same way here, we are arranging by year primarily and then by continent. Make sense? So, okay. So why might it be useful? Well, maybe you're displaying it, and like someone might want to look at it. Maybe what you want to do is you want to know like the richest country for every year, but not just the one. You want everything, but you want the richest country for every year to be at the top. So you might do something like arrange by year, and then within the same year, break ties by GDP per capita. So I'll actually make this, and then I'll view it to see. It's kind of interesting to see. So this one actually. So here it's like the poorest first, I guess, which is kind of a bummer. So we'll do minus GDP per capita. And here you get, so sort by minus, it's the same as sort from largest to smallest. So here in 1952, you see that Kuwait is at the top. Canada is actually doing pretty well, although 11,000, well, without inflation, that's pretty good. And then somewhere here, so 72, scroll up. Okay, so where does 72 start? Yeah, so here, so Kuwait is actually still on top. Switzerland is now way up there. Saudi got up there. Libya is doing great. So yeah, that's actually kind of surprising. But yeah, so something like that. So just kind of to view the data. Sometimes it's useful to arrange it. Sometimes it's useful for intermediate analysis as well. So we have something like this. So what else? So what else can we do? So we have and I forgot filter here, which we already had. So we have filter. So I'll do this because it's easy, and then we'll do a break. So filter you already saw. So this is just take rows with a certain property, right? So we already saw kind of like simple properties, like year is 1952 or something. So that would be just the data for 1952. So what's an interesting property that you could have? Well, we just wanted to look at the richest country for every year using GDP per capita. So an interesting property for a row to have is that its year is as large as possible. Its GDP per capita is as large as possible. So what can we do? Well, we can say, and again, this is the kind of thing that I think would take some thinking. But you can say, okay, I want to filter, but I want to filter the grouped one, and it's going to be grouped by year. And I want the GDP per capita to be as large as possible among the group. That would be like this, right? So here what's going on is here, after we say group by, this means that anytime we process anything, we're just processing group by group, right? And here we're saying Okay, like filter the rows and only keep the ones where the GDP per capita is actually the same as the maximum GDP per capita. It's grouped, so that's the maximum within the group. And here you have the results. So Kuwait until 92. A bad thing happened to Kuwait in 92, as you might know. And then was invaded by Iraq. Went away from the league tables, and Norway, which also has a lot of oil and wasn't invaded for quite some time now, got to the top. And then, so here you see 82 is for some reason out of order. Nobody guaranteed that everything is going to be arranged by year. Of course, we can fix that by saying arranged by year, right? So here, like, we have the result, and then I want to say, okay, arrange whatever we have there by year. Right? And now you have it sorted. Good for Norway. All right. So again, kind of this, I would say, is a highly, like, it's not like anything too fancy, but it's like a non-trivial thing. So we'll practice more, and you'll see how that works out in the coming weeks. So I think we should take a break until like 8:25, I'd say, and then we'll continue. So what we have left is mutate, which is not going to be super easy, distinct, which is pretty easy, and then we'll do some exercises. What are people saying on Discord? So at least kind of here, has everyone installed tidyverse? Okay. Okay, cool. Yeah, so group by is not really related to arrange, right? So arrange is just about the order in which the rows show up. Group by is kind of the complicated thing. So group by is saying I have this data frame, and then I want to process it group by group. So for example, group by country would mean that you have one group that's just the rows for Angola, and another group is just the group for Australia, and so on. So that's kind of marking out the groups. So I see the connection that you see, which is that, well, like if you arrange, then the groups are going to be like one group of rows all contiguous, another group of rows all contiguous, and so on. But arrange just rearranges the rows. It doesn't group them. It's just that it happens that if you then do group them, then they're all going to be contiguous. Group by doesn't change the order of the rows. It just marks them out as like those are the rows for Australia and those are the rows for Canada, and so on. If we submit homework with ChatGPT 3.5, yeah, I mean it's okay. So I think it's not ideal because ChatGPT, so the 3.5 GPT can just be misleading about whether you got it correct or not. I don't care as far as kind of grading. The grading in this class is kind of fake anyway. but it's maybe not as good for your learning. So if you can, you should get ChatGPT 4. Yeah.
How does summarize, like what are the parameters of the summarize?
So summarize, it's name of the column that you're creating. So here, for example, where's my summarize? So it's saying I want to have, so in the result here, for example, the one column is going to be country, so that's the names of the groups, and then whatever other stuff I want, I just say I want that. So for example, I say I want the column max life expectancy, and then I say what that column is, what that column should be.
So it collapses like all the vectors into one, right?
Basically, well, so not one, but so the result is a table with as many rows as there are groups, right? So here, for example, there's 2 groups, so there's going to be 2 rows in the output for summarize, because you have one maximum life expectancy for Canada and one maximum life expectancy for the US. So the thing maybe that's a little bit misleading is kind of for filter and stuff like that, you kind of get the same kind of table. Summarize, it's not like that, right? You got a completely new table. The only thing is that one of the columns is going to be the names of the groups. Yeah. What is G? So G is just like, I was just saying that G is this data frame. I mean, it's not. It's fake. Like, it's not R. I just kind of pasted it so that people see that this is the table that I'm talking about.
It's kind of like a function, just looks at every single data and does and then collapse all of them into one. Yeah, summarize it across groups. If you don't give summarize group, it just processes exactly that. So you can just calculate the summarize will have all these right. If you do summarize it will not be just summarizes. It just gives you each group has more data. Yeah, I guess that's what it does. It removes everything. It's like you summarize this column. This country has like 10 countries. This country has like this data. This is the same group, right? So it's one country. This is also the column. And they have this property of expectancy. So if you summarize, they collapses all this into one correct, into one particular. Oh, really? Yeah. Yeah, just however you want. You can collapse this into like the total life expectancy, average life expectancy.
All right, now. So what it looks like you're using looks like you're using posit.cloud. So it should be like some kind of download button or download thing in your menu rather than save as, maybe, because like you're not actually running it on your computer, you're running it in the cloud. There another way to analyze data frame or do similar stuff to summarize. What don't you like about summarize? Kind of one answer is we'll kind of do those things a little bit kind of at the lower level manually in ESC 180. So that's kind of one answer, but like in R, it's like if you want to do summarize, yeah, you kind of need to do summarize. That's why it's there.
Select rows or columns?
Say again?
Can I select rows?
Selects columns. So rows is selecting rows is filter.
Oh.
No, you can't. So no, you can't do it like that. This was just kind of to show people what the table is. I'm not doing it. This is just kind of the tracing notation. It's not real, right? You can't do it in R. All right, 825. So okay, so we have. Where's my stuff? So we have distinct. So distinct. So we saw unique very briefly. So distinct is distinct is make it so that there are no duplicates. So if you just say distinct without anything, you need to really create a data frame that does have duplicates. So here I'll make one. So it's going to be like just fake columns. So like 1, 1, 2, and then B is going to be. So I need like duplicate things here. So I'll say kind of 1, 1, 2 again, and I'll say C is 2, 2, 2, like this. Happy again, so that's just because I forgot the commas. So df looks like this, and you see that this row and this row are the same. So I can say df distinct, like this, and that'll give me just the same thing except without the duplicates. So that's sometimes useful, not very often. So you can also say distinct A. So in that case, what you'll have is just distinct version of A. You can also say, I want like all the possible distinct combinations of A and B, right? So what are the possible combinations of A and B? Well, you have A equals 1, B equals 1, and you have A equals 2, B equals 2. Right, so this would be like this. So that's sometimes useful. So on Gapminder, maybe not so much. On baby names, it's a little bit useful. So if you load baby names, okay, I'll just load it here. Then you might like to remove some of the duplicates there, right? So maybe you want like all the different names there are. Well, you can do it. You can say baby names distinct name, and that'll just give you all the names. And that gives you information about what are all the names in the data set. So apparently 97,300. 300 names. Well, a little bit more, so plus 10 because the 10 were displayed. You might say, oh, but actually, for example, so it's kind of like, I guess now it's famous, but because like there's like a character on the new Star Trek who's named Michael, who's female. But yeah, like Michael can be usually a male name, but sometimes a female name, right? So let's say that I don't just want like distinct names, I want distinct names for the different gender. So like if Michael is both male and female, I want kind of to say, okay, like there's like Michael female and Michael male. How can I do it? Well, I'll say distinct, and I'll say name, and then I think it's sex there, right? And here you'll have this kind of thing. That's really weird. How come it's so much fewer? Oh, it's not fewer, it's a little bit more, yeah. Right, so from this, by the way, you can figure out how many of the names are like unisex, right? So like this much minus this much is the number of names in the data set that are unisex, well, that were assigned to male and female. Right? So that's sometimes helpful. So the other thing you can do is mutate. So mutate is compute a new column. So for example, going back to Gapminder, so just kind of as a quick refresher, does everyone know what GDP per capita is actually? Well, not everyone put their hands up. So GDP is the gross domestic product. And that would be the total amount, or like the total monetary value of everything produced in the economy minus total amount destroyed, actually. So in economics, this is called depreciation, right? So if you just have like a house, usually it does go up in value, but technically, like it goes bad, like things break, that part is actually subtracted. So there's two ways to compute GDP. So this is like not an econ lecture, but like one way is to see how much stuff was sold. The other way is to see how much stuff was bought. Those in principle should be equal because whatever was sold was also bought. So GDP per capita would be just GDP divided by the population. Right. So okay. So in Gapminder, you have GDP per capita, and it kind of makes sense, kind of from a data science point of view, a lot of the time, because kind of you want to know kind of how rich the country is, and by that you mean like how much do people buy on average per person. If a country has a lot of people, there's going to be a lot of money spent, but maybe everyone's poor. Right, or not everyone, but some people. So sometimes, though, you want to know you want to know the GDP. So if you want to know which countries are kind of influential and important, well, like Norway is very rich per capita, but it's not a very important country because its GDP is not that high. It's just that GDP per capita is high. On the other hand, you have kind of larger countries that are like on average not that rich, but together have a lot of resources and can like whatever, like send people to the moon or like build nuclear weapons or whatever, right? So let's say I want to compute GDP. So the way I would do it is using mutate. So in mutate, I'll say I want a new column. I'll name it GDP, And GDP would be GDP per capita, which I already have, times the population. So the GDP per capita here, let me remind myself. It's actually in dollars, and the population. Yeah, so I'll just do it. So I'll do it like this. So just so I can read it, I'll do it in thousands of dollars. So I'll just divide by 1,000. And now we have a new table. I'll name it GGDP or something. And that's going to have the GDP. And here you can see, okay, like which country when was the richest. And so in this data set, which ends in 2007, so America in 2007 was the richest. As you know, China is basically is about to overtake America. I think at this point, I think it has overtaken America in terms of the GDP. Not sure. You can check. Okay. So, although in 2007 it was like half, so maybe not yet, but it will. So that's like that. And it's pretty straightforward. So you just say, okay, like this is how I want to compute the new column GDP. It's just GDP per capita times pop, and it does it kind of row by row. All right. So here's something that's kind of like slightly more, this is like very much more complicated, so I'm going to show it to you, but I don't really expect you to kind of be able to reproduce it. So let's say that I want to know the share of world GDP for each country for each year. So, for example, I want to be able to say, like in 1982, this is an example, I don't know, we'll see what the exact numbers are in a second. So I want to say something like in 1982, like USA accounted for, I'm guessing it was like 20% of world GDP, but we'll check. And I want to do it for every country for every year. So how would they do it? So this is not a job for summarize, because I want the same kind of table just with an extra column. So this is his job for mutate. On the other hand, the way I would compute the world GDP is I would sum up the GDPs of every country for that year. So I need group by. Right? So that's what I'm going to do. So I'm going to say Gapminder, then I'll group by year, because what I want to do is for every year I want to compute the sum total world GDP. So I've grouped by year, and now I say mutate, and that's going to be GDP share, and GDP share is going to be, so I start with Gapminder, so I'll start just with the raw GDP. And now I want to divide it by the total world GDP for that group. What's the total world GDP for that group? Well, it's just like the sums of all the GDPs. All right. So that's what I'll do. I might need to do it in 2 stages, but I think that should work. I might have messed it up, and yeah, no. Yeah. In 52, yeah. Yeah, and so I said like in 82, 22, so yeah, I was pretty close actually. Yeah, like because this is a little bit of a data science class, this is like also the time to talk about kind of what you want to measure and what you don't want to measure. So GDP is in some ways an imperfect measure. So going back to the healthcare system, so one way in which you can increase GDP is by increasing the price of something. And then if it's really expensive and people buy a lot of it, that increases GDP because people buy a lot of it. So on the other hand, so Canada to some extent does price controls for medical services. In part, like, well, if you have price controls, you have a shortage, so that's why you would have a long wait time for a specialist, for example, is because it's free, so many people want it, so you have to decide how to allocate that, and part of it is you just have a line, and the people who most need the service stay, the people who don't. But you know, like if something is expensive and people buy a lot of it, that increases GDP. If, for example, in one country, childcare is being taken care of informally by family, then that's considered money not changing hands, so that would not contribute to GDP. On the other hand, if everyone's watching each other's kids and sending like payment for that via Venmo, that does increase GDP. So that would be a situation where the total amount of child care is basically constant. Someone's taking care of the kids. But if it's informal, then that doesn't contribute to GDP. If it's formal and money changes hands, then that does increase GDP. So imperfect. And certainly kind of part of why the GDP of the US is so high is because money changes hands a lot for a lot of services, which in other countries money would not change hands for. Also, they're generally very rich and make a lot of stuff, so it's part of it. So that's like that. So going back to the programming, so what have we done here? So this is just a straight formula, so this I think is straightforward. On the other hand, this is kind of mysterious, right? So here when we're doing this, it's just a formula. What do we mean by GDP share? What do we mean by GDP, rather? It's like GDP per capita times population, right? When you're saying sum, you're taking this entire vector, in this case the vector is GDP per cap times pop, and then you're summing it up within the group. And that's exactly what we wanted, is we wanted to divide the GDP within the group of the year to get the world GDP. So let me trace it. Actually, no, you'll trace it for homework. Have fun. All right. So that's that. So someone asked about select, which I forgot about. So select is pretty straightforward. It's just that you get to say, I want to keep just a subset of the columns. So you can say, for example, select GDP per cap and country, and leave out everything else. And it'll just leave out everything else. That's kind of all there is to it. So this is not like that in kind of other environments programming languages, but yeah, like in R, like I answered to you. So if you want to just keep a subset of the rows, that's filter. If you want to keep a subset of the columns, that's select. And that's just how it works. All right. I think what we'll do, so we're like almost done. So I think what we'll do is I'll just say bye, and I'll answer whatever questions on Discord, but the lecture is over. The people who want to stay and do a few exercises, I'm going to indulge you. But you don't have to. Like it's also kind of late. So compute the number of countries in Gapminder So when I say Gapminder, I mean like in a Gapminder like data set, because of course, like if I just say Gapminder, you can just look it up and say, oh, like this is the size of Gapminder. So to compute, so I computed the number of countries in Gapminder, and it's actually sorry, this is wrong. Of course, this is number of rows, but I mean in a Gapminder like data set. And then I want you to write a function that computes the number of countries in a Gapminder-like dataset. So just the same thing, but just make it a function. And then right, so that's the exercises. And let me see what's on Discord. Okay, this seems like hash nerd face thing. Can we get the exercise on Piazza on Discord? What is showing? Group by year and group by country are different. Yes, pasting overhead in R. I'm not sure what you mean by overhead, sorry. Oh, no, it's here anyway. All right. Okay, bye. Thank you. So I'm stopping the live stream. I'm staying in class, and I'll check the Discord if there is anything, but the live stream is over. I'm not going to say anything.